is about series, how to test their convergence and divergence and find their sums. Now, so far we know geometric series, harmonic series, telescoping series, how to find the sum if it is convergent. We have also the integral test, the comparison tests. Today we will study a new type of series that is called alternating. We will see together what we mean by alternating series and how to test them for convergence. And we will have also a theorem about estimating the sum, how to find the number of terms needed to estimate the sums. Regarding the estimation, Shabab, let me confirm that. Now, the estimations that we have in 11.3 and 11.4, they are not included. Now, what is the only part or the only section that you have estimation for the number of terms is 11.5. So it is almost guaranteed that you will have a question about estimations of the number of terms. We will study this today, inshallah. So what we mean by alternating, you know, alternating what it means. So the alternating series is a series whose terms are alternately positive or negative. So when you have positive, negative, positive, negative, positive, negative, or negative, positive, so it is alternating. Usually the alternating sign, Shabab, when you have positive, negative, positive, negative, usually we will denote them by -1 to the power n, or n minus 1, or n plus 1. It depends on which term is positive, which one is negative. Okay, now these are examples about alternating series. So this is 1 minus plus minus plus. This is an alternating series. You can write it in using sigma notation like this. This is of course 1 over 1, 1 over 2, 1 over 3, 1 over 4. It is 1 over n. And for this positive, negative, positive, negative, so you will start with positive. So you will write it like -1 to the power n minus 1 or n plus 1. It doesn't matter. It is the same. For this one, it is 1 over 2, 2 over 3, 3 over 4, 4 over 5, 5 over 6. So it is n over n plus 1. For the negative positive, it is negative, positive, negative, positive. So you will start with the -1 to the power n. In general, the alternating series, the nth term will be written this way or this way. Usually we will use this one, Shabab. To start with positive term, we will use this one. So indeed, this Bn here is positive. Look, this Bn here that is next to the alternating sign, this one. It is positive term. So Bn is greater than 0. It is indeed, Bn is the absolute value of the nth term. Okay, what is the alternating series test? So shortly we can call it alternating series test, or shortly also AST, alternating series test. What is this test is about? It says that if you have alternating series in this form, طبعا again يا شباب, it's okay if you put n plus 1 and it is just alternating. So what should this satisfy to be convergent? So if Bn plus 1 is less than Bn and the limit of the nth term is 0, then it is convergent. What is part 1 is about? This means that Bn is what? It means that
decreasing.
Is decreasing. So this means that it is decreasing. And this means that that Bn, the second part, means that Bn goes to 0. So I'll combine these together, ya shabab, and I'll say just what? Bn decrease to what? To 0. So when I mean this, I don't mean that Bn just goes to 0. No, it decreased to 0. So it means that it is decreasing and its limit is 0. So if it is decreased to 0, then it is convergent. Otherwise, you need to use another test because this test is just about the convergence of the alternating series. So if The alternating series test says if the terms of alternating series decrease towards 0 in absolute value, then the series converges. Excellent. Now, let's start with this example. Look at this series, 1 minus a half plus third minus third. Here it is. I want you to look at this and ask yourself, what is Bn? If you compare it with the standard form, Bn in this case is what? 1 over n. If you notice, it is decreasing. Why it is decreasing? Because n plus 1 is greater than n. So if you take the reciprocal, it will be less than. 1 over n plus 1 is less than 1 over n. So this implies that Bn plus 1 is less than Bn. And this is the first condition. It is decreasing. Now also, what is the limit? What is the limit of 1 over n when n goes to 0? So shortly, just write it this way. Bn goes to what when n goes to infinity? When n goes to infinity, this goes to 0. So shortly, we will write this as I said, yes, it decreases to 0. Combine these two conditions in this way. What do you notice, ya shabab, that you should relate this to another series, this one, 1 over n. What is this series, ya shabab? Do you remember what we call it?
Harmonic.
This is harmonic.
Harmonic series.
And it was divergent or convergent?
Divergent.
Divergent.
The harmonic series is divergent, but the alternating harmonic is what? Convergent. We just show that it is convergent by the alternating series test. Remember that we will need that in the next section in 11.6. Another example here, ya shabab. طبعا I forget, ya shabab, to mention if you want to study the convergence or divergence of any alternating series, I advise you to start with the condition 2. Check the limit. If the limit is 0, go to the studying the decreasing or increasing. But if the limit is not 0, you don't need to continue like here. So here, don't waste your time looking for is it decreasing or not. Just check the limit. If you notice here, what is Bn? This is Bn, ya shabab. The term that is not included in the alternating issue. So here, what is the limit? When n goes to infinity. Clearly, ya shabab, you have the same degree over the same degree, so it is 3 over 4.
3 over 4.
So it is not 0. So according to this, condition 2 is not satisfied. So no need to check condition number 1, ya shabab. Here, you cannot apply the convergent test. So in this case, what we can say that condition 2 is not satisfied. So we cannot, because all what I can have here, ya shabab, if these two conditions are satisfied, then it is convergent. If one of them is not satisfied, we cannot use this test. Okay, because we cannot conclude because the conditions are not satisfied. But here, ya shabab, clearly that you can use another test for divergence. So you are, I'm sure that you are saying now it is divergent because the limit of Bn is 0. But of course, this test doesn't say that. It says that if these two conditions are satisfied, then this is convergent. In other words, it says if it is divergent, then both conditions are not satisfied. Now, if you just look at, we want to say that this is divergent. By which test, ya shabab? What is the test that can help us here to say that it is divergent?
Divergence test.
The divergence test, which is the limit when n goes to infinity for the whole one. -1 here, we have -1 to the power n times 3n over 4n minus 1. The whole one. This one equals to what, ya shabab? We say that this is 3 over 4, so it will be positive or negative 3 over 4, which does not exist because it is not unique. So it is not 0. So because of that, this series diverge by the test for divergence. The test for divergence 11.2. What does that say? The test says if the limit is not zero or does not exist, it is the series is divergent. Let's take one more example. Now again, ya shabab, always try to check the first condition. What is Bn? Bn is this one, the term that is the positive part, that does not contain the negative signs. So Bn here is n squared over n cubed plus 1. Is the limit goes to 0, shabab, when n goes to infinity? Is this goes
Yes.
when n, because the degree of the denominator, of course, just divide by n cubed, look. And this is 0, this is 0, 0 over 1 is 0. So it is 0. This goes to 0. So the second condition checked. Now you can go to the first condition to check. The problem here that it is not easy, ya shabab, to decide that this is convergence of divergence by comparison. Of course, you need to show that that n plus 1 all squared over n plus 1 all cubed plus 1 is less than n squared over n cubed plus 1. You can use cross multiply. You can use cross multiply to show that, but in most of situations, it is not easier than using the first derivative. So it is better, ya shabab. It is better to work. It is of course not obvious that it is decreasing. So we need to consider the related function. This is the nth term, the Bn. This is the related function. Now find the derivative, the first derivative. You need the first derivative for this function to be decreasing. You need the first derivative to be what? To be negative, to be less than 0. For this one to be less than 0, you need what? Of course, the denominator, ya shabab, is positive. So we want the numerator to be negative. So this will be negative if and only if the numerator is negative. You can find the correct numbers, but it is easier than that. Now, ya shabab, remember that here we are talking about n greater than or equals 1. So here our x is greater than or equals 1. So here x is positive. So this one is positive. So this will be negative if and only if this is negative. For this one, it is positive. Don't worry. So it will be negative if this is negative. And of course, this means that negative x cubed is less than negative 2, which means that x cubed is greater than 2, which means that x is greater than the cubic root of 2. Cubic root of 2, ya shabab, almost what? 1 point something. Am I right? So this means that x is greater than 1. And remember that x here is, we are talking about n basically. So we can say that x is greater than or equals to 1 point something. So start from 2. So this means that this is decreasing. For the function, this is what we have. For the function, it is decreasing for x greater than this. Now for the sequence, for the series, for the Bn is decreasing for what? We don't have a shabab 1 point something for the integers, so we will say when n is greater than or equals 1 point something, it means that it is greater than or equals to. So this function is decreased. This is decreased to 0 for n greater than or equals to 2. So now we show that it is decreased towards 0 for n goes to infinity. So it is what? According to that, it satisfies both conditions of the alternating series test. So by the AST, the alternating series test, it is convergent. Now let's come, shabab, to the most important part. Usually, as I told you, most of the questions will be about this part, estimating sums. As you know, shabab, we can decide if we have alternating series, we can know if it is convergent or divergent, but we cannot find the sum. If it is convergent, we don't know what is the sum of this. So we can estimate the sum, or at least estimate the error in calculating the sum. So this theorem says that if we have a convergent alternating series that satisfy the conditions of the alternating series test, then the size of the error in calculating the sum is smaller than Bn plus 1. So it is bounded by Bn plus 1. What is Bn plus 1? It is the absolute value of the first neglected term. What is that? Means that we will find B1, B2, let's start with positive, B1 minus B2 plus B3 plus minus B4 and so on, until we have B minus 1 to the power n minus 1 Bn, then Bn plus 1. So we will find the sum from here to here. This is Sn. This is Sn. Now the difference between the exact sum and the Sn, this will be, of course, ya shabab, Sn. It will be less than the neglected term, the term that we canceled, that we stopped at. So this will be less than the term after the nth term. Okay, so if we have S as the sum of the series, where Bn here is positive, Bn is the positive part, is the sum of alternating series satisfy this. I forgot to mention this, ya shabab, that in from 11.2 up to 11.4, we assume that always the nth term is positive, at least eventually positive, ultimately positive. In this section, we now allow it to be positive or negative An, so which we call it Bn. In the next section, we can deal also with negative when we have negative terms, not necessarily alternating. Now, what we said, if we have a series that is convergent, alternating series, this is only for alternating series, ya shabab. If we have alternating series that is convergent and its sum exists, then these are the conditions that it satisfy the alternating series test. Then the difference between the absolute value, the difference between the exact sum and the approximated one is always less than Bn plus 1. And this is amazing. It will be always less than the term after the nth term. So if you calculate, n is 10. So the difference between the exact sum and the sum of the first 10 terms, it will be less than B11. So this is what this theorem says. We will have many exercises about that. So in other words, if you want to recall this in words, this says that the error, this is the error, ya shabab, is of course bounded by Bn plus 1, or always less than Bn plus 1. This is an example from your textbook, example number 4. I modified it a little bit. Show that it is convergent. This is easy. Just you need to check these two conditions. Let's start with the first one. So here, what is Bn? Bn is 1 over n factorial. Clearly, shabab, this goes to 0 when n goes to infinity. How to show that? Use the squeezing theorem. You know that n factorial is less than 1 over n, because n factorial is greater than n, of course. So the reciprocal will be like this. So also it is positive, so it is greater than 0. So this goes to 0, this goes to 0. Of course, the one in between will go to 0. So for the second condition is clear. Also for the first condition it is clear. How to do that? It is clear, ya shabab, that n plus 1 factorial is greater than n factorial. Am I right? Clear, because you know that what is n plus 1 factorial? It is n plus 1 multiplied by n minus 1 multiplied by n factorial. So this is clearly greater than n factorial, because here we start n greater than or equal 0. So it is at least greater than or equals, if you want to say. Now, because of that, we have, of course, the reciprocal, because both are positive. Of course, Bn plus 1 will be less than Bn, or equals, no problem. If you have, of course, here n equals to 0, they will be equals. So this part is easy. This is not what we are talking about. What we are talking about is this: how many terms of the series do we need to add in order to find the sum, or to the accuracy, the absolute value of the error is less than 0.0002. Now, how many terms we need? I advise you, Shabab, in such case to do the following: to write few terms at the beginning to get an idea about what is going on. So what is the first term when n equals to 0? Be careful here, we're starting from 0. So here what we will have, ya Shabab, negative 1 to the power 0 over 0 factorial. 0 factorial is 1, by the way, by definition, ya Shabab. 0 factorial is 1. So here we have 1. So shortly, we have 1 minus, when n is 1, what we have? Negative 1 over 1, it is also 1, plus 1 over 2 factorial, minus 1 over 3 factorial, plus 1 over 4 factorial, minus 1 over 5 factorial, and so on. Okay? So this will give you an idea about how many terms we need to add to get this list done. For some series, you can do that by calculations, but of course, you need to do it without that. Now, what we want, ya Shabab, we want the error. This is the error. According to this theorem, because it is convergent, it is an alternating series that is convergent, then we need this to be less than Bn plus 1. So to guarantee that the error is less than this, we will make this also. So what we will do, we will say Bn plus 1 is less than 0.0002. So this is what we will do. If this is less than this, of course, because this will be here, it will be less than or equals. So this, if this is happening, then of course this will be. As I said, it is bounded by Bn plus 1. So if you want to solve this inequality to get, this is what we want. This is what we want. To get it, we should put Bn plus 1, the bound of this, the bound of the error, less than also 0.0002. And what is Bn plus 1, ya Shabab? What is Bn at the beginning? Ask yourself, what is Bn? Bn is 1 over n factorial without negative, ya Shabab. Look at the standard form. Now, this is Bn. So what is Bn plus 1? Bn plus 1 will be 1 over n plus 1 factorial. Here it is. Bn plus 1, it is 1 over n plus 1 factorial. Now, you have this inequality. How to solve it, ya Shabab? You can cross multiply or reciprocal. Both are positive. So if you apply the reciprocal, this will be n plus 1 factorial over 1, which is n plus 1 factorial. 10,000 over 2, 5,000. Now, we cannot solve this, ya Shabab, algebraically. If it was like n plus 1, لو كانت n plus 1 greater than 5,000, this is easy. It means that n is greater than 4,999. Okay? But this is not the case. N factorial here means what, ya Shabab? Means n plus 1 multiplied by n minus 1 until 3 to 1. So it is not easy to be solved algebraically. So what should we do in this case? In this case, we should start thinking about what is n, that if we put here, we will get the factorial greater than 5,000. So it is natural, ya Shabab, to start like what? What do you think? What do you suggest here? Let's start with n equals to 4, for example. If n is 4, what we will have? We will have 5 factorial. This is 4, 4 plus 1 is 5. 5 factorial, ya Shabab. Who knows what is 5 factorial? 5 times 4 times 3 times 2 times 1 times, what is it? 120. 4 factorial is 4 times 3 factorial is 6 times, it is 24. 24 times 5 is 120. So this is 5 factorial. So it is really, is it greater than 5,000? No, it is less than 5,000. So think about the next one. What do you think? If n is 5, what we'll have? We'll have 6 factorial. What is 6 factorial? Is this times 6. So it will be 720. It is still less than 5,000. Let's go to the next n. What is the next n? N equals to 6. What we will have if n is 6? we will have 7 factorial. 7 factorial is 7 multiplied by this 720. Clearly يا شباب this is equals to what?
5040.
5040 is it greater than. So what is our n that we are looking for?
6.
But the question is the question about n or about how many terms? How many terms? So what will be the answer? How many terms يا شباب?
7.
Why 7?
6.
Why 6?
Because we have n equals 6.
Because we have n equals to 6, Muhammad Al-Amri. At least you have a reason. But who said 7 يا شباب? Who said 7? Why 7?
Me, Doctor, sorry. I didn't see the n plus 1. Sorry.
You are right, ya Turkey. It is 7. It is 7.
Okay, I'm not sorry.
Don't be sorry at all, ya shabab. If you did a mistake, it is not a big problem. Now, ya shabab, n equals to 6. In fact, the answer is 7 terms. Why? Because look, from where the series is starting?
From 0.
From the 0.
So we have 0, 1, 2, 3, 4, 5, 6. How many terms? 1, 2, 3, 4, 5, 6, 7. We need 7 terms. So it is 7. طبعا usually يا شباب the series that we will have, they will be solved algebraically. So this is not the case when I have noticed in the old exams that most of the exercise can be solved algebraically. This is a remark that says, shortly I will summarize this remark for you. This rule, what we did here يا شباب, this rule. What we did here is only for alternating series test. It does not apply to other type of series, so be careful. Now these are some suggested problems. Today we will solve inshallah the recitation. Here I selected these 2 exercises for you, Shabab. I also put the answers for you here to practice, and we will go to practice the old exams because you know in the old exams they know that you don't have a calculator, so they will give you something that you can calculate by mentally, of course. Read the question carefully, and please, if you have an answer, raise your hand and tell me what is your answer. Read it carefully. Let S and the Sn be respectively the sum. So this is the sum. And Sn is the nth partial sum of the series. This series is alternating series. So you can apply the idea of the absolute value of S minus the absolute value of Sn is less than or equals to Bn plus 1. Okay? Because it is alternating. If it is not alternating, you cannot do that. Then the smallest number of terms n needed such that, so he is asking about here the number of terms, ya shabab, or the number of, or n, because in some questions they ask about n. Here they ask about the smallest number n. طبعا here the same will be the same. The number of the terms will be the same as n. Why? Because we are starting from where? From 1. So they will be the same. The number of the terms is the same as the value of n, such that the error is less than 0.01. Please, ya shabab, take 1 minute, please, and tell me your answer if you have an answer. It is easy. Just apply what I told you before. Sufyan?
20, doctor.
So you are saying that the right answer is E?
Yes.
We will see. So to have this, ya shabab, we will put this less than the given condition. So what we will do, you will say that Bn plus 1 less than 0.01. Continue now. What is Bn plus 1? Ask yourself, what is Bn? Look at here. Forget about the alternating sign. It is 4 over n squared. This is Bn, ya shabab. Don't do a mistake. Most of the mistakes that students here consider Bn, not Bn plus 1. So what you have here is 4 over n plus 1. 4 over n plus 1 all squared. This is less than 1 over 100. Now, ya shabab, خلاص, it is a matter of an inequality. You know how to solve inequalities. So you can do here cross multiply, you can do the reciprocal. So here you have n plus 1 all squared over 4 greater than 100. Multiply by 4, it will be greater than 400. Now take the square root of both sides. N plus 1 all squared greater than the square root of 400. This is n plus 1 is positive, so no need for absolute value. So you will have n plus 1 greater than the square root of 400 is what? 20. So n is greater than 20 minus 1 is greater than 19. So it is 19, yeah. Yeah, Sufyan, you said 20 or 19? So what
20,
is n?
doctor.
N equals what? N
20.
greater than 19. What is the smallest? The smallest number greater than 19. Smallest integer, of course. It is 20, and you are right. Great, ya Sufyan. Is it clear يا شباب؟
دكتور كيف جات 20 smallest number هذه ما فهمت.
Again, please.
أنت قلت إن smallest number
N greater than 19 يا محمد القحطاني. محمد. N greater than 19. What is the smallest number greater? What is the smallest integer greater than 19?
فهمت.
Okay. Here he is asking about the smallest, even if he didn't, by the way. طبعا any number here, any number greater than 19, it works. But we want, ya shabab, to minimize the work. Instead of, it means that what is the minimum number of terms that I need to add to each other so that the error will be that small. Okay? But of course, n equals to 21, 20, it is, but he is asking about the smallest one. Okay. Is this idea clear, ya shabab, for you? If it is clear for you, you will solve this one, the next exercise. Either way, this one is solved here, but let me give you this. Please, ya shabab, now solve this one. And let me also launch polling for you to answer. So the answer is, I will launch polling for you to select. Please, ya shabab, take a pen and paper and start. Read the question carefully. Is he asking about the number of terms or the n here? Using the alternating series estimation theorem, the minimum value of n, is it the same as the number of terms here? No, because it starts from 0. But here he is not asking about the number of terms. Be careful. He is asking about the number of the minimum value of n, for which the nth partial sum approximates the sum within this error. It is less than 1 over 10. Let me remind you again, shabab, here what you need the difference between s minus sn less than or equals bn plus 1, which means in this case that you want it to be less than 0.1. So you need this, you need to work on this. bn plus 1 less than 0.1. Just ask yourself, what is bn? What is bn plus 1? bn is the nth term, the absolute value of the nth term. Forget about the negative or positive. So it is this one. This is the nth term, the cubic root. The cubic root of n plus 4. Now the question is, bn plus 1, what you want bn plus 1 less than 0.1. bn plus 1 is 1 over cubic root of n plus 1 plus 4, it will be plus 5. Less than 1 over 0.10. You have a polling يا شباب. I see some raising hands. Who's raising his hand? You can choose يا شباب. So we have now many answers. We have E, we have C, we have B, we have E, A. Only D that we don't have. So only 22 students participate so far. (26 out of 41), 27. This is good. 65% has participated so far, 70% now. Let me now stop ya shabab and show you, because I almost done. I solved it for you. Look at the results. 16 students with A, 3 with B, 8 with C, and only 3 with E. And the right answer is A. So the majority were right. Now يا شباب خلاص, it is a matter of solving this inequality. So take the reciprocal now. You will have cubic root of n plus 5 is greater than 10. Now to solve this inequality algebraically, you need to cube both sides. So you will have n plus 5 greater than 1,000, and which means that n is greater than 1,000 minus 5, n is greater than 995. So what is the smallest, the minimum value of n that is greater than 995? N equals to what? To 996. The first number greater than this one. The smallest one that is greater than this. طبعا يا شباب, you can check. By the way, I forgot to mention this. Always you can check. How to check يا شباب? Go back and put n here. Go and see if it satisfies this or not. It satisfies for sure. If you take a number that is smaller than this one, you cannot. If you take, for example, this, okay, you will not. It will not satisfy. Check. If you substitute, you can use a calculator to check. Just if you put here instead of this, you will not. It will not satisfy. No need for a calculator even here. For 995, of course, if you bought it, you will get 1 over 10. 1 over 10 is not less than 1 over 10. But if you bought 996, you will get something that is less than 1 over 10. Clear? Let's now, Shabab, go to practice the recitation exercises. We have 4 recitation exercises that they are so easy. So I will not spend so much time on them. So here you need to test this one for convergence or divergence. Just ask yourself, what is Bn? It is 1 over 3 plus 5n. Let me write it here. Bn is 1 over 3 plus 5n. What do you think, Shabab? Is it the limit is 0? Is it goes to 0 as n goes to infinity?
Yes.
So is it decreasing? Yes, Shabab. This one is increasing. Its reciprocal clearly will be decreasing. You can apply, of course, you can say that 1 over 3 plus 5n plus 1 is less than 1 over 3 plus 5n. Check that by the cross multiply. So what we can say here, Shabab, shortly, that this decrease to 0. So it satisfies the condition. So this one, what will be your answer? Your answer will be, it converges by what? By the alternating series test. Let's take another one. I will give you now 2 minutes, 1 minute, 2 minutes to solve this. Test this series for convergence. Is it convergent or divergent? And tell me why. Please, if you have an answer, you can raise your hand. Convergent or divergent, and why? Abdullah Abdsalam.
It is convergent.
Why?
By the test, when you take the sign n plus 1 plus half as alternating part, we have pi over 1 plus the square root of n. And when we substitute with the infinity, the limit for infinity, it will give me 0.
Just a minute, Abdullah. Is it alternating?
With sign, I think yes. Because sign, it will be between 1 and -1.
So what we mean by alternating, yeah, Abdullah, alternating, it means that it is like this, -1 to the power n, or n minus 1, or n plus 1, something here, something positive. So do we have this case here? This is the question. Don't apply the alternating series test for a series that is not alternating. Abdullah, you are right, but you cannot justify, you didn't justify your answer in the right way. Anyone other than Sufyan, Shabab? Let me ask you this. I advise you, Shabab, always to write few terms. Always, I told you that. Write few terms at the beginning and you will see what happens. Now, what is sine? What is sine? In fact, let me write it here. What is sine n plus a half by? In fact, it is sine 2n plus 1 over 2 by. And if n is, this one is Shabab, if n is 0, what you have? If n is 0, just take n equals 0. You have sine pi over 2. What is it? 1. If n is 1, for example, what you will have? If n is 1, you will have sine 3 pi over 2. What is this? -1. The next one will be 5 pi over 2. And it will be 1. 7 pi over 2, -1. In fact, in general, this equals to sine n plus 1, n plus a half pi equals to positive or -1. Is that right? So we can write it like this: sine n plus a half pi equals to -1 to the power. Is it starting with positive or with negative? With positive. So let's write it n minus 1.
Doctor, what about the pi?
Yes, it is here. It is without pi. It is not true. The pi is inside sine. Yeah.
Oh,
It is inside it, Sufyan. The pi, it is inside it. It is mentioned here. So indeed, this one, Shabab, here, this one here is just -1. Here it is. So this is a hint. This is the trick in this question. So this is why I put it for you in the solution. Look, this series, Shabab, it is just -1 to the power n. Yes, we start from 0. We start from 0, so no need for n minus 1. N is enough. N is enough because we are starting from 0. So now this series is just -1 to the power n over 1 plus square root of n. And of course, Shabab, clearly here that bn will be 1 over 1 plus square root of n. Yes, ya Muhammad.
Can they apply the same trick with other trigonometric?
For cosine, if you have
Cosine,
cosine,
yes.
cosine n pi, مثلا. Not only cosine n pi, cosine 2n plus 1 by sine n 2n plus 1 by over, just like this. This is equals to -1 to the power n. This is equals to -1 to the power n. Okay.
Right.
So now this is 1 over, this is bn, Shabab. It is clearly decreasing to 0. Clearly, check that. So it is convergent by the alternating series test. Now this is about show that this series is convergent. How many terms we need? So here, first of all, how to show that it is convergent. This is easy. I'll do it for you. There is a trick here. Also, it is alternating or not? Is it alternating, ya Shabab? It is not in the standard form. The standard form of alternating is like this. So you need to do here one more step to write it in the standard form. What is it? -1 to the power n. This is -1 to the power n. The 3 will go down. So it will be n times 3 to the power n. Now it is in this form. What is bn in this case? It is 1 over n times 3 to the power n. Now clearly, ya Shabab, this decreased to 0. When n goes to infinity, this goes to 0. To infinity, 1 over infinity is 0. And also it is decreasing. Check that by check that bn plus 1 is less than or equals bn. Check by the cross multiply. Now, or of course, you can use also the first derivative test. What I am interested here now is how many terms we need to add to get in order to get the sum less than this. So here what you need to do, you need to find bn plus 1 less than 0.0005. So what is bn plus 1? In fact, bn plus 1 here is what? Is 1 over n plus 1 times 3 to the power n plus 1 less than 5 over 10000. We have 10,000. Now take the reciprocal. Greater than 10,000 over 5, 2,000. Is that right? Now you cannot solve this algebraically, so you can think about what is n. So if you think about n equals what, like what, for example, n equals 4, what we will have? We will have 5 times 3 to the power 5. What is this, Shabab? This is 5. If you have a calculator, we can save our time, Shabab, but you can solve it even with our. So this is 81 times 3. So this is like 5 times 3, 3 times 8, it is 240. Is it greater than? I don't think so. This is less than, Shabab. This is less than 2,000. Whatever it is less than. So let's go to n equals 5. This will be what? When n is 5, this will be 6 times 3 to the power 6. What is it? It will be 6 times
4,374.
1 times 81, because this will be 81 times 81. Okay, so it will be for sure 6 times 8 is 486 times 81. For sure it will be greater than each other. Am I right?
Yes,
So this is
4,000.
the first one. This is the first one that will make it greater than Muhammad. You're right. You are raising your hand, Muhammad, for this or for other reason?
Sorry, for other reason. For previous.
Okay, no problem. So n, ya Shabab, is 5. So he is asking about my series starts from 1. So here 5 terms. The answer will be 5 terms. Okay, I'd like to solve also in the remaining minute, ya Shabab, I'd like to solve this interesting question also. For what values of p, this series is convergent? Now you should think about, ya Shabab, special cases. The first special case that you should think about here is when p equals to 0. What will happen if p is 0, ya Shabab? If p is 0, this series should be like this. Over n to the power 0 over 1. So it will be like this. This is what we have. If b is 0, and this one is what? This one now, the limit of the nth term. I prefer to just focus on the nth term, the nth term. So what is the nth term? The nth term is negative 1 to the power n minus 1 over n to the power b. Now the limit, if p is 0, I'll just, ya Shabab, take 1 more minute from your time to record. I want this to be included in the record. So if b is 0, what we have? What will be the limit of an when n goes to infinity?
1.
Sure?
Yeah.
No, it will be limit n goes to infinity for negative 1 to the power n minus 1. And this does not exist, ya Shabab. It is positive for negative 1, does not exist. So it is divergent in this case. The series is divergent. Okay? Now, if b is less than 0, if p is less than 0, it will be the limit of the nth term. It will be the limit of negative 1 to the power n minus 1. Now, because p is negative, what we will have? This is negative, ya Shabab. So it will be in the denominator. Like think about n to the power negative 3. So it will be n to the power here. It will be, you can write it to make it more clear. You can write it negative 1 to the power n minus 1 n to the power negative 3. This goes to positive or negative infinity. It depends, طبعا. So that does not exist as well. So it is not 0. So also diverge in this case. Check that. Now the last case that we still have, when it is greater than 0, what will be the limit when n goes to infinity for negative 1 to the power n minus 1 of n to the power p? Clearly, ya shabab, this is what? Zero,
Zero.
because if P is positive, it will stay in the denominator. So it will be positive, it will be positive or -1 over infinity. So it will be positive or -0, which is 0. So in this case, it satisfies the condition of the alternating series test by the limit goes to 0. Now, is it decreasing 1 over n to the power b? It is clearly what?
Yes.
Forget about this, by the way. We are applying now the alternating series test. So forget about it. We are applying the alternating series test. So alternating series test here. Now this one, shabab, is decreased to 0 because you know that n plus 1 to the power p is greater than n to the power p if p is greater than 0. This means, of course, that the reciprocal is less than, and this means that, of course, that bn plus 1 is less than bn. So it is decreasing. So it decreased to 0. So this one now is convergent by the alternating series test. And this shows that this series converges for p greater than 0. So that will be the answer of this question. Thank you, Shabab, and this is all what we have for today.